What is up, mathletes? Welcome back to the episode of Math with Dr. Math. And today, let's talk about that conditional probability. Don't go anywhere. All right, mathletes, I hope you got your ovens ready because it's about to get hot in this kitchen. All right, so before we begin, don't forget to smash that like button, subscribe, so that other mathletes can be as lucky and as ready as you are. All right, so let's go ahead and let's dive into conditional probability. What we're going to be looking at is we're going to be finding the probability that something occurs, that something takes place, given the fact that something else already happened. All right, and what we're going to do today, what we're going to focus in on is we're going to focus in on using these contingency tables where we're going to look at two things happening. All right, so in this case, what we're going to be looking at are people either that have graduated, maybe got an associate's degree, bachelor's degree, advanced degree, and we're also going to be comparing whether they were a man or a woman. All right, so we're going to be comparing these two things. So let's look at, we'll start off slow with what we already know, and then we'll build, we'll move forward and get closer to this idea of what is conditional probability, how do I use it? So follow me. All right, so we got this information here, right? So we're going to be looking at certain degrees, or if a person graduated, or how far they went along with their degree, and then we're going to also look at if they were a man or a woman. All right. So, and remember, these numbers are in millions. All right, so let's say we select a person at random. All right, hey you, yeah, you get over here, I need you. All right, and we're gonna look to see what is the probability that this person is a man. All right, so the probability that this person is a man. So what we do naturally is we say, all right, how many men do we have? Because we're only looking at the men. So we have 94 million. So our regular probability would be 94 million divided by the total. And so we got the total. Let me just add them up here. And what's cool about this table is what I did, and I need to talk about this, is I added all the men and I put that value here. I added all the women and put the value here. So now let me go ahead and calculate our grand total here, and we got 195, right? 195 million people in general, so one out of 195 million. So this proportion here is going to describe the probability that the person was a man, right? So remember, the number on top is what we're actually looking for, and out of the grand total, right? And then we could go ahead and divide this, and remember, when you're dividing this in your calculator, make sure you put that 94 first and then divide it by 195. Because again, a lot of people, they make that mistake. And if your answer is greater than 1, you know you jacked up somewhere. All right, so be careful. All right, what is the probability that the person is a man with a bachelor's degree? So when we say with a bachelor's degree, we're saying that the person is a man and has a bachelor's degree. So we use our tables, we look at where these two intersect. So these are all my folks with the bachelor's degree, and these are all my men. So I want to see where those two intersect, and they intersect right there. So it's going to be 17.5 divided by the grand salami of 195. All right, so there we have it. So this is what we've already seen. So now here's the new stuff. All right, so the new stuff, here it comes. What is the probability that the person has a bachelor's degree given, underline that word given, make sure you know what it means, that the person is a man? So whenever we say given, what that's going to tell us is we're only focusing in on a certain group. In this case, because it says given that the person is a man, we're only looking at the men, right? So the grand salami on the bottom, that number on the bottom, is going to be the 94. Right? Because that's our total that we're looking at. So again, we're not looking at everything. Tunnel vision here, we're only looking at the men. And that's what conditional probability is we're not looking at everybody, we're only looking at a certain group. In this case, we're only looking at the men, which is the 94 million. And then out of those men, only the men, right? How many of them have a bachelor's degree? So 17 million.5. And there, my friends, is how we calculate the conditional probability. All right, ready for some more examples? Let's do it, Johnny. All right, mathletes. So example number 2, let's hope this isn't you, but 200 patients who had either a hip surgery or a knee surgery were asked whether they were satisfied or dissatisfied regarding the results of their surgery. All right, so we have this chart here, and we're looking at two things: what type of surgery they had, right? That's what we got going on here, and then their satisfaction level, right? And notice what we did is we went ahead and added all the grand totals, and these two, right? This total down here should equal 200, as well as this total. So regardless of how you add it up, the columns versus the rows, you're gonna get the same number, all right? So here we go. If one person from 200 patients is selected at random, all right, determine the probability that the person was satisfied given, there's our key word, right? Given that the person had a knee surgery, right? So we're only, when it says given, this is the group we're focusing on, the people that had knee surgeries. So how many people had knee surgeries? Boom, 95. So that's our number on the bottom. 95, because we're only focusing on those that had knee surgeries, right? So out of those 95 folks, how many of them were satisfied, right? So we see that 70 of them, right? That's what it tells us, 70 of them were satisfied, all right? So again, hopefully this is starting to click. Hopefully this is starting to make a lot more sense. If so, don't forget to like the subscribe button. Like the subscribe button? I guess you could like the subscribe button, but smash that subscribe button. And again, make sure you share this video with some friends, right? We need your help. And let's say a person was dissatisfied given that they had a hip surgery, because as you know, it's all about those hips, right? So given that they had hip surgery. So the people that had hip surgery were hipsters, and they were 105. So there was 105 people who had hip surgery, and out of those 105, right, how many of them were dissatisfied, right? Shakira was not one of them, and so 15 of them. So 15 of them were unsatisfied, they were dissatisfied with the surgery. So that's what we're looking at right there. And again, we could take out our old friend Julio here, and let's see what Julio gives us. 15 divided by 105. Boom. And everyone give it up for Julio. He's been working hard all year long. So 0.1429. Boom. Thank you, Julio. Pleasure working with you, sir. All right, is it making sense? Follow me to the next one. All right, mathletes, so this one's for you, right? This is our big test. So part C, example 2, make sure you comment down below. And what we want to know is the probability, right, that someone had knee surgery given they were dissatisfied, right? So we're only looking at these folks that were dissatisfied. They weren't very happy, folks. So let us know that probability down below, and let's check our work. All right, before you go, better not be leaving. Make sure we look at this example. Let's get one more example under our belts. All right, so we're at a zoo, and a sampling of children were asked if the zoo were to get one additional animal, right? Would they prefer a lion or an elephant? All right, so would they prefer a lion or an elephant? And we also wanted to look at if they're boys or girls. All right, that were for the people taking the survey. All right, so if one child was surveyed, right, at random, find the probability that the child selected the lion given the child was a girl. So we're only looking at girls for part A. So we see that the total number of girls were 160. So once again, that number on the bottom, when it says given, is only going to represent that group that we're looking at. So the total amount of girls. And out of those girls, we said, okay, how many of those girls chose the lion? So we know that 75 of them, right, felt like a lion. They wanted people to hear their roar, right? So 75 of them. All right, so the Katy Perry reference. Should we delete that? All right, so part B. The child is a boy, right? The child is a boy, but given the child preferred an elephant, right? Because an elephant never forgets. Is that right? All right. So they preferred the elephant. So given the child preferred an elephant, so we know on bottom it was 195 because we're only looking at those children that preferred the elephant. So out of all those children that preferred the elephant, how many of them were, boom, boys? And so the elephant crew, boom, 110 of them were boys. And it's that easy, folks, all right? So we have 2 questions for you. So we want you to try out these 2, so check them out. All right, if you have Julio on demand, right, make sure you get Julio out so you can answer these questions. So part C, what you're doing is the child selected is a girl given the fact that they preferred a lion. So again, remember that number on bottom as you're going through the work, you're only looking at the lions and how many of them that preferred lions were girls. And part D, the child preferred the elephant given they were a girl. So in this case, the number on the bottom is the number of girls, and we're looking at, out of those girls, how many preferred elephants. All right, comment down below what you got, mathletes, for your answers. We'll compare answers, and we'll see you, mathletes, in our next video. Peace. All right, mathletes, thanks for watching. And again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching, and we'll see you guys next time.